All right, good morning, everybody. I'm Mary Thomas. I'm HPC training lead and a computational data scientist at SDSC, and I'll be presenting Introduction to Git. So this is the basic GitHub overview, Git and GitHub. And if you want to be in the advanced Git and GitHub session, that's in the other breakout room. So with that, we'll get going. This talk is based on one that was written by Marty Candas and we do annually. So well, I'll be probably going in and out of the presentation, but at the beginning there's not a lot of hands-on, but we can do some hands-on exercises once we get into the parts of the presentation where there's some work that you could do. So I'll probably jump in and out of the presentation. All right, so we'll go over version control and the motivation for using Git and GitHub, and talk about Git and how it works. And then starting with the getting started, we can do some hands-on exercises. And as I said, we have plenty of time today to try and give you guys time to work with it if you haven't. At the beginning, it can be a little confusing and perplexing. Where am I wondering where your files are and how you change them and what happens when you do make changes. And then we'll do some other Git command work, and then look at GitHub, which is an online repository system. So Git you can run just right on your laptop and have your own local collection, and then you can also put it on GitHub if you want to share it with people. And then we'll conclude the talk with some other tasks. So it used to be that we didn't have Git to store and version control everything. And so versioning and keeping track of, as many of you know, keeping track of all the different versions of code as you're developing it, or data as you're taking a lot of experimental measurements, it can be quite complicated. And so numbering things, it can be very, very helpful. And that's why we have version control and repositories. There's version control in a lot of different applications, and not only just for software, but other things would be controlled with version. It's just this process of storing your information and keeping track of the changes by putting a name or a number, or for me, I might put the date on this talk and where I gave it, so that's a different kind of version control. But if I keep presenting the same topic and I make little changes to it, then I put the date on the event that I present the topic at. And that's a version control. So there's all kinds of ways to do version control. And when you're in a software development project or a big project, keeping track of the version controls just by numbers, it's consistent. Everybody's using the same system. It's not dependent on how Mary chooses to name and number something, and she's working with Cindy and Susan, and they're naming and numbering things differently. So you get some consistency, and that gives you data provenance and some history and an ability to track what you've been doing. And even with your scientific data, version control is a good idea. Now, GitHub, there is a limit for the size of data you can have on GitHub because it's a free repository, but version control can be applied with different software systems. Anyway, it's good for tracking what changes you've made. So how do we do it? The files we're interested in, you want to, from a software perspective, is how we'll view it in this talk today. You're basically going to be looking at your software source code. That's what we'll talk about today. So there's an article on best practices for scientific computing, and in this they talk about how in practice everything that's been created manually should be put in version control, including programs, field observations, and source files for papers. Just anything you need to organize your program. And this is a cute little cartoon. I don't know if you guys have heard of PhDcomics.com. They're pretty funny. But this is the scenario of a graduate student or a student working and giving the advisor the final doc capital FINAL. I know we've all used that. I used it this week for the final doc that got submitted, and it is actually in its 4th revision. So this happens even without version control. So it just shows the scenario going into 8 revisions, 18 revisions, 22. So making fun of it, but it's actually very helpful to know which version do you have when you look at one that you're working with today and you think, well, I need to go back and make a change. What was the version and what was in the content 2 months ago or last year or 5 years ago? And in this example here, Marty is showing that he did his own versioning control with a very logical linear numbering system for his dissertation work, I believe. And this was a while ago, and he used Dropbox to organize. Probably this was done before version control was as readily available through GitHub as it is right now. So you can version control in lots of ways, but you do want to have some logic. We version control all of our presentations in sort of a date timestamp. That among our training group, we have that practice for the videos and the transcripts and other materials associated with training. So it's very useful, and it does matter. And so what's a version control system? It's a software tool that helps you record and manage changes you make to your files and your documents. And it keeps track of every modification you make. So in this scenario up here, these are tar files that are compressed, and there is a record, but there's no, is a record that stores the contents, but how the contents changed in Marty's Dropbox document version control system, it's not tracking all the little changes that you make. When you move to something like Git, you're looking at every single change that you made. Change one character, it gets recorded by the version control system. So this is much, much, much more detailed. And that is also very important if you're working on a team or just making a lot of changes and you want to depend on what version of your software that you've got. So if a mistake is made, you can go back and find where that little mistake bubbled into your code and recover. And so I have worked on a big project with several people, and there have been times when 6 or 7 people are working on a complicated code with different components in it. Somebody does find, oh, this isn't working, or a mistake was made, or just some change that no one, that everybody agrees should not be there, or your module that you're working on needs to be recovered. So you go back, you get that version that you were working on. Yeah, we'll talk about this. You do something called checking it out, and you check it out, you make your changes, and then you remerge it back into the main software software track. So it's very helpful for that. And when you're on a project that goes on for a long time, it's helpful. So examples of other version control system is Apple's Time Machine. And you can visually, they show you a visual graphic. And you can go back in time and look for documents maybe that changed or you deleted, so you can go back and recover them. Excuse me, Dropbox has versioning control as well. Microsoft Word will track changes for you and also has some versioning control. And Wikipedia has versioning control. So here is a snapshot of viewing the logs for this page. Google Docs also has versioning control. There's versioning control on a lot of different applications. And so how does it work? So you kind of keep track of what you're doing, and it's like a record and then playback in time. So you have some initial base version when you start your repository, and every time you make a change, that gets recorded in a log file. And then that log file eventually has a lot of changes in it, and you can go back and rewind back to the start of the base document, or go back to some intermediate phase, a change. So how does it work? There's a concept called branching. This one might be the hardest one to wrap your head around, which is by having this history of changes to this document, and you start looking back in time, you can pull out you can pull out the repository and work on it independent. So now what we have is maybe a scenario where two people are working on the GitHub repository, and they both make different changes, and later on you'll merge them back together. It works well, and GitHub will track if the both of you are working on the same part of the code uh, or the document. But in this case, we'll just talk about software. And if you do, the system will let you know, hey, you have a conflict. There's been two changes made to it, yours and another one on a different branch. And you can decide to merge the changes from that branch in to your document or not. So you have control as well. And then, at some point, if you can't, if what they're doing and you're doing are the exact same line, and I've had this happen, then you meet up with that other person and you say, hey, which one should we keep, and work that out. But it does let you know, and so you're not working in the blind. And if changes are made, you get informed. These are the changes, and when you check it out, you'll merge back in the changes that you want. So it helps facilitate collaboration among multiple contributors to a shared document, and also not only collaboration with other people, but with what you're doing. You might keep a main branch, check out a sub branch, and work on a little part of it, and then merge your work back into the main branch so that the work you're doing doesn't affect the main branch. For example, if you have production software and you don't want to touch that production software because other people are checking it out and doing work with it or using it, you check out a branch, you do your work, and then everything's fine, it tests fine. You merge it back into the main branch, and your changes will get propagated to everybody. And they'll know because when they check out even the main software repository, if they have also a copy of it, they'll be told when they try to push a change, hey, there's been other changes to the repository, download all those changes, and then Git will look for conflicts. So even though you're working remotely and not talking to each other every day, the Git repository and Git control software will track that for you and let you know when there's correlate when there's changes and conflicts in the changes. Okay, so the version control works by merging. So now these two people who are working on these two different branches need to get all their work back into one main branch. So when you want to share your changes, you merge those changes back into the main document. And like I said, if somebody else has been working in the repository, you'll be made aware of that, and Git will check to make sure that you aren't all working on the same document or the same part of a document. So as long as there's no conflicts when the contributor tries to upload their changes, then everything's fine. It'll get reintegrated back into the main branch, and everything's great. And if not, you'll get warnings and have to resolve how to manage those document changes. Okay, so the benefits of using a version control system: you can archive your software, and you need to regularly save the changes that you make. First of all, that way you can track the changes, and in the event that something goes wrong, you aren't trying to understand 55 changes. You might be looking at 5 or 10 changes at a time. So it also gives you a controlled source of information and tracking. It facilitates reproducibility. You can create a history of your saved changes, because every time you check your software back into the Git control system, you have to make a comment. So you can say, I changed the subroutine XYZ in the main module, and this affects something. So you can make the log entries as complicated or as simple as you want. And that's also very helpful for you to be able to reproduce and also check out what you did. And it facilitates collaboration, obviously, between you and a team of contributors. But you also can be just working on a project on your own and still, get that ability to track what you're doing. Accountability. This gives you accountability even of your own work. You can compare changes, and if you are working with a big team, you can see who last modified something, which will let you know if things are great. You can go, oh, cool, Mary got that subroutine done, so I can use it now. I've been waiting for that. Or there might be an issue, and you can say, uh-oh, Mary has a little bug in her code that in her test system, maybe I'm not testing the same modules and subroutines as you are, but there's a side effect. So that accountability is a good thing to have. And on large software systems, it makes a difference. And then there's recoverability. Each contributor has a local version and a recent copy of the project and the history of what they've done, and then it gets checked back in, or they have a copy but they haven't affected the master copy, so to speak. And so it's easier to recover from mistakes and changes. And like I said, I could make a change to my code and it's all working fine for the test case that I'm testing. But then there could be a side effect and it could be a big problem, it could be a little problem. But with the Git system, where you track every change that's made by everybody, you know what change, you can trace back to what change occurred and recover that. We were working on a document just yesterday, a very important one, a whole group of us, and somehow a part of the document on Google Docs, which has version control, a full sentence disappeared. It was a document for a report, and somebody noticed it was missing. So we actually went back and looked through all the changes that had been made there were 8 of us working on this collaboratively, and went back through their version history, found where the sentence disappeared, and recover that sentence. So it can be extremely valuable. No one knows how it happened. We didn't bother about that. It's just we found it and it wasn't lost because we had a version control system supporting our work. Okay, so if there's any questions, you can take a moment to see if there are any, or are they being answered in the chat by, I think, Mahi. If not, we'll move on.
We don't have any questions in the chat.
Okay, thanks. All right, so let's keep going and look at Git. Git is one of the most popular repository software management systems around. There's been a few in the past, and this one seems to have managed to survive. Git is a distributed version control system. It was designed to be really simple and fast. And a little fact was it was created in 2005 by Linus Torvald and his team of people who were working with a proprietary software control system as they developed the Linux kernel. And then they got mad when they lost the right to use it, or maybe they wanted to charge them a lot of money. So they wrote their own. And out of that has come a really nice, lightweight, and flexible system. It's usually installed by default, but we'll go over how to install briefly this morning. How is it different? It has, it's got centralized and distributed features. So centralized is whenever you make a change and commit it, you send it back to a centralized repository server where it is tracked. This makes sharing your changes with others immediately available to other people who are on that server as well. A common server is GitHub, but there's other companies and projects that use Git and manage your repository. GitHub is very popular, and we'll talk about that this morning. And then there's distributed, where the changes are committed and shared with others who have their own repository, and the repositories need to communicate with each other. So you would commit your changes to a private repository, maybe on your local computer, and then you don't need to be connected to a network, but it's harder to propagate your changes to the collaborative group. This is just showing you the difference between private and public repositories. On the left, we have a shared repository, and these three individuals all share and store their code on that that shared repository, or public in the sense that it's available to more than one person, but there's still going to be access control. You can choose to have that, like make it private, so other people can't see it. In this one, it's a distributed repository where each of the three team members have their own local repository, and they give permission to others to access it. So each contributor who's sharing changes on a project has these two repositories, a private one that's going to be on your laptop and a public one that will be on the centralized server. Okay, so the workflow for Git is you would be working on your private repository, which is the one on your laptop. And it's important to realize that this is on your laptop or your local system. All the changes that you're making are local. It's not shared by anyone else until you're ready to share the changes you've made. Nothing will be seen by the other members of your team, for example. And you have to share and commit your changes to the team repository in order for them to see it. You can make your changes, and once you're done and you're satisfied that they're what you want them to be, you then commit them to your private repository, and you can review your committed changes. And then you can share them when you're ready by pushing your changes back to the team's shared public repository, or your own individual, depending on how you've got it set up. And then do a pull request from your public repository to the team's shared repository. So there's a cycle. We'll go through it a little bit as we actually work on the GitHub repository. Any questions at this point?
We don't have any on the chat.
Okay, all right, fine. So getting started, we have to install Linux, and in this I will go into a shared mode, and we'll see how this works, jumping between the presentation and actually doing work. So Git is installed by default on my terminal, and this is a login session for Expanse. But if I open this up and make it a different color so we know that the blue is my local laptop. And you're welcome to try and go along with this. I'll make the font bigger and make the screen smaller, and try this on your laptop. And then if I move too quickly through the material in order to make sure we get through it, there's about 80 slides and we're about halfway through, we will come back and hopefully have plenty of time for you to give it a try and ask questions. So I'm on my laptop, and I have Git already installed, so it's right there and available to me. And I can, look for help. What I notice for Git is if you use -H, you get a summary. If you do help, you get a lot more information. And for those of you who are new to Linux and Unix, that's pretty standard for a lot of the Unix commands. Okay, so if you want to install it on a Linux-based system, you should be able to do so, assuming you have the operating system a permission and the package management tool. So if anybody needs to install Git, let me know. How about a raise of hands if you need to install Git? Otherwise, get on your laptop if you want to try and do some of these commands as we go along. Otherwise, we'll save it all for the last maybe 15-20 minutes of the talk. Morteza, I see your hand is up. Do you need to install Git? And what kind of laptop do you have? You'd have to unmute if you were going to answer the question.
Yeah, we've got a smaller group, so Mary, you don't mind if people unmute and ask their questions with you, right?
I don't. And I think we're good on time, especially the installation. So I'm assuming his hand's up, but it's not urgent and you can try and install it. Sometimes it takes a while. So I'm going to move on through and then we'll get back to you at the end and see if you need any help with that. But this slide here does give you instructions on how to do that. He's not responding, so I'm going to move on through. What slide is this one? Get to my next slide. Okay, and you can install it on the Mac OS. You shouldn't need to. You should be able to. Most systems come with Git installed on them. And that's why I use that command, which is a Unix command for finding anything, like which SSH. So SSH, I can't type. Which SSH, you can find out if you've got it. And if you don't, it can take a while. So we'll try and help you if you have problems. Otherwise, lower your hand if you don't have a question. So you've got it installed, so you should be able to install it if you don't have it. So for Mac, you use packages, and for Windows, I'm sure it's the same. So you can also install it under Windows, which I don't have, but if you go to this repository here, then you can download the code and install it from there. And you can Google it and find it and install it. You can put it onto VMs. Like I said, though, most modern systems like Windows 10 and the OS, Mac OS, they tend to have it already installed. So when you start using Git, though, for the first time, you have to do some configuration stuff. And these are really helpful slides. When I learned Git, nobody told me about this. And I was learning it sort of in that need-to-know mode. I was on a big project and with lots of software. And so it was like, what do I need to do here? And so git config is a really useful command to automate some of the tasks that you do in Git. So you have a couple of files that you may or may not have on your computer, like an etc config. It contains system-wide configuration variables. It doesn't exist on the Mac OS, but that's okay. If I look for that command, I don't have it, but my Git works, so I'm not worried about that. I do have a local.gitconfig file. That should be a tilde. Well, I have to give it a command. It's not an executable. You know what they say about live demos, right? Something always can and will go wrong. So that was just a typo for, I want to list, there it is, and we'll look at the contents in a moment. And then you might have a local one in your Git, your local Git repository as well. So there's different files that store different information. Every time you clone or download a repository, you'll get this local.gitconfig file. So you want to set up your identity with git config. And so, for example, this is my git config. I'll use the cat command to look at the contents. And I have a lot in it. I don't use everything in it, but I do keep things in here like my email address and things like that. And so git config, you can load it in using the git config global, which will put it into the command, the git config file that's in my home directory. And you can also put information into the repository git directory as well. So in this example, you're adding the user.name and the user.email. So I'm not going to change my git config file. So otherwise it would mess up my large number of repositories. But they're important because it's included in all the Git commits that you make in order to provide that history. The dash dash global option places these values in that git config file that's in your home directory. If after you set up your identity, you can configure the text editor. I don't worry about that, but you can tell Git that I want to use Emacs. You use the editor mainly for entering things into the log file and some commit statements. And so, but you can tell it what kind of editor you want to use. Otherwise, if you don't tell Git that you want to use something in particular, it will just pick up your default editor. Like I use the VI editor on my terminal window. It's not the editor software you would use when you open up Word, for example. That's its own, it has its own internal editing. It's just what you would use when you're doing things with Git. So in addition to your identity and text editor, you'll probably want to make sure you turn on color highlighting in Git's user interface. So you could have this Git config. Now I don't have that in mine at the moment. And so I do actually have it, but let's see if I try this command, it should still be the same. So I'll show you an example of running the Git config auto. And so I check what's in it, and there it is. The user interface is auto. That's how you make that work. And then what's in my git config file? I can run this command to see what's in Mary Thomas's git config file. And that's a summary of all the stuff you see when it's catted, but this is actually an object, and it's got, it's an object type file. So you have all these different pieces in it, a credential, my username, my user email, and aliases. You can alias commands inside of Git, which is kind of nice if you like to use aliases. I do a lot. And when I'm doing heavy Git writing and debugging, I use some of the aliases. Let's see. And so this is how you would replace one of the variables in there. I could make a change by changing the user email. So you can check the value of just that one command. Okay, so the configuration is important because it makes it easier to make changes to your code as you're working on it and get connected to the repository. So if you need help, you can type git help or git help command. There you go. And the GitHub documentation is very helpful. And often what you get when you have something happening, like you get a message from the Git system, like you're merging and there's a conflict because up on the remote repository, somebody else made changes. It'll remind you, you can't check in your changes because there's changes in the base. So pull it back, pull the changes down, and then try to merge your changes. And that's how you can get things, you can control conflicts. And so getting help is right there. And then if you're running it locally and still the help command doesn't give you the information you need, there's a plethora of online Git tutorials. The internet is full of them, and so just search around and keep track of the ones that you're finding, and after a while you'll collect 2 or 3 links that always work for you. They're written in a way and a language and just a tense that makes sense to you. So out of the 100 ones you might look at over time, you might find 1 or 2 that every time you go there, you're able to understand how they're writing, how they're explaining whatever challenge you're having at the moment. So keep track of that, especially at the beginning. If you've not used Git very often, it can be a little confusing. Which branch am I on? Why aren't things working? Rebase, what's rebase? What does it mean? And so getting that help is very nice to have those links tracked so you can go back to repositories that make sense to you. Everybody's individual. So are there any questions at this point? Okay, if not, we'll move on to the next section where we look at doing some work with Git. And this is where it becomes really interesting. So you want to go to some path where you have a project and then you want to init. So this would create a new subdirectory. So what I'm going to do is there's an example in this talk, and I'm going to go to the place where I do my development work. And I have a place where I store work with SDSC, and I'm going to make a directory, and I'm going to call it Git Planets, because this is a particular example that's in this talk. And I'm going to go into Git Planets. So I'm in my, oops, PWD, I'm in my working directory, Git Planets. And now I know this is, and I've never used this, it's not on my system, it doesn't exist anywhere. I have a lot of repositories. As you can see, there's quite a few, but right now I'm in this one here. So, all right, so nothing is in here. So the first thing I want to do is I want to make this directory into a repository. So I use a command called git init. Now you can make a new repository on the laptop, and later I'll show you guys how to make a repository on GitHub, which is a web-based server, very popular. You guys have probably already used it if you've done anything with Git. Okay, so I have a message that says I've got something built up, and I need to, if I want to configure it, I can. I'm in this empty Git repository. Okay, so the next thing is I've got this repository, and now in here, Marty shows some details. I'm going to make a directory in this repository and call it planets. And so I've got this directory, and then you have, I'm going to go into that and start making some files. I'm not tracking the time at the moment, but I think what we want to do is I'm going to glance through these, and then we'll revisit them once I go through all of them, and we'll do the exercises together. I want to make sure I cover all the material, and I'm thinking it's quarter till, and we have until 9:30. So I do think I want to finish with this introduction and then come back and actually do the work at that point. So I'm going to go back into SlideShare mode with my talk and move through some of this material. So again, we've made that repository, and it is a Git repository. And in particular, you'll see this little .git, which is a folder that holds all the Git configuration information needed to manage this one repository. It has nothing to do with any other Git repository that you might download or make. They're completely decoupled and completely independent. But they would be if you had this repository also hosted on GitHub, for example. It would be coupled to that one repository on GitHub. You can even make multiple copies, and those multiple copies don't affect each other if they're in different directories. So anyway, we have the status. We're on the master branch, and this was the initial commit. And there's nothing to commit at the moment because you haven't changed anything. If you make a file, it even tells you what to do next, git add. So again, we're on that master branch, the first branch for this repository. Each file in your repository's directory can take several states, and the main tool you use to determine which state the files are in is with the git status command. The states can be, a file is either untracked, it hasn't been committed and stored into the repository data system, or it's there but it hasn't been modified, or it's there and has been modified, or and once modified, it's been staged to be committed. So files are in those four states. If I go in and edit the file, it becomes marked as modified. So Git senses and looks for changes of the files in the folder or the directory, and then I can choose to stage the file to be committed, and so it becomes staged. I don't have to stage every file I've changed. Mostly you do, but if I choose not to, it'll just sit there as modified. Once I stage the files, then I run the command to commit, and I could choose to remove this file if I want to later on, but I have to let Git know if I remove anything. So tracked files are all the files that Git knows about and has under version control. And untracked files are everything else. Like if I had a C source code and I compiled it, I would make an executable. I don't necessarily want to commit the executable, so it would remain in that directory as an untracked file. And you can identify files as untracked and tell Git to ignore them. That's a different command. We'll talk about that later. Or I could just ignore the fact that Git will tell me when I type git status, there's a file there. It will tell you it's a file that you need to make a decision about. So here we create a file called mars.txt by echoing a statement into this file. That's a Unix redirection or a pipe type of command. And that file is there, and when I type git status, it says you're on branch master. It's still the initial commit, and you have an untracked file, and it's highlighted in red. That's the advantage of using that color that we set up in the Git user interface. Nothing added to commit, but untracked files are present. Use git add to track. All right, and so we're going to take that modified untracked file. This file that we're working on is untracked, and so we'll add that to be staged to be committed by typing git add and then that file name. You can either just put the file name in or the full path to the file name. So you can track and work in a particular subdirectory and then bring in changes in files you made in other directories as long as you use that full path. When you run git status again, you'll see that Git is aware. Here we've typed git add, git status, and now it's marked new file, changes to be committed, new file mars.txt. So this file is now ready to be added into our GitHub repository. So what happens from a data perspective is I'm making changes to this file. In green, there's a change that hasn't been recorded. I add that to the staging area, and now by doing git add, it's been staged in this area here, and now I type git commit, and that gets the changes get committed to the repository and the actual code, the file. So when I type git commit, I need to stage this, and before when you do the commit, you want to add comments, and you'll get that opportunity when you do. Notice that I do git commit. I don't have to put the file name because I've already added it and staged it to be committed. Commit requires a commit message, and so when you don't specify a file, then you'll be prompted with an editor, or you can do one in the command line. If you choose your format, you can choose a format to commit. And here's some guidance on 7 rules to writing a great git commit message. Excuse me for a little background noise there that I had to get rid of. Okay, so I didn't in this command here. I wrote git commit with no other messages. So git by default then will put me into my editor that I prefer, which for me is just VI. For Marty, it's something else in this example. Please enter the commit message for your changes, lines with the pound. Hashtag sign will be ignored, and an empty message aborts the commit. So there's just new file, changes to be committed. And here's the input for the log file that will be created. Added my initial description of the planet Mars in mars.txt. Okay, and so that has happened. The commit, changes to be committed, git commit, and notice the message, the log file message got typed out to let you see what your commit message was. And then do git status on branch master, nothing to commit because now we've committed and got that change entered into the Git database. And to see what your commits have been, you can look at this log file that gets created. This is one of the files that are in that .git directory. And so added my initial description of the planet Mars in mars.txt. So I think we'll go end show, and I'll try and do these really quickly. So I make a directory and call it planets and vi mars.txt, and then Mars is a planet. I'll just keep it really simple so we can do it quickly. I'll type git status. There's untracked file, git add mars.txt, git status, and then git commit, adding mars.txt file, and then I will change it, and then git push. Okay, live demo. This command on my laptop is working different. Oh, I forgot, I'm on my local repository on my laptop and it's not remote, so I don't have to push the change. I'm in such a habit of working with repositories that are on the GitHub repository. I make changes, I store them, and then I push them to the remote one. But because this right now is on the local Git system running on my laptop, I don't need to do a push. But I can look at the log file. And that, what I wanted to show you was in that in the repository information directory is the log file. So that log file, when I typed git log, here's my information. It gives you a lot of information. And so these comments, sometimes you need to make really informative, detailed comments. And sometimes if you're in a repeat and save, and you're making several changes and testing them, your log file entries may be very simple and terse. Okay, so that gives you an example of how that works. Go back into the presentation. Okay, so it will show commit history by default. Okay, so in this slide here, we create a few more files, earth.txt and pluto.txt, and they'll show up in the directory, the changes and comments. The data will be in these files. But no changes added to commit. That's why they're highlighted in red. And then again, we have new untracked files that we need to stage to get them committed. So in this slide here, we're going to add both files. You can do more than one file at a time and make a commitment. In this example, we're just doing it from the command line. That's the way I prefer to do it, because it's faster, and also I can use the up arrow key to recall commit commands and maybe modify them or just repeat them. Added this file, made another change, and updating the change to this file again, kind of thing. So it's git commit -m, and and you put it in quotes, your comment. And so hit return, added the initial descriptions as the comment here. Git will tell you that 2 files were changed. Here they are, earth.txt Pluto, and I do get status on branch master. No changes staged, but one file has been modified. So it's like, do you want to commit it or not? So you have to decide. Again, if you make changes, you do a git add, and in this case, you add the file that is being tracked, but you let git know that this file that has changed or been modified, I want to add it to I want to commit that change. And so you can do git add and or git commit -a. And again, we do a commit and we look at the log to look at the changes that have occurred. All right, comparing differences. You can, with git log, it gives you information about commit, but also you can look at the specific changes made to the file. So you can run a command called git diff for differences. That's a Unix command. You can diff 2 files just that are in your repository, but Git will look at the information that's stored in the Git repository log files and the information stored in its database. So you're going to do git diff on files that are in Git, not just 2 files that are in the system. These are only going to tell you, the changes that it's tracking. But if you have a file that Git is tracking and you've made some changes to it, but not committed it, Git can also see those differences. All right, so here we look at the status. We've modified Mars.txt, and we're wondering, wait, did I modify that? What did I change in it? Let me track that. So you run git diff, and it gives you information about Mars.txt A and B. And A is your current file, and B is the one that's in the repository. So you've got the 2 changes here, and you can say, okay, yeah, I did want to add that comment. And so then we would commit that. So the first line tells us that Git is comparing the old and new versions of the file with the diff command. The second line tells us exactly which versions of the file are being compared. The next 2 lines show the name of the file, and the remaining lines show the actual difference, with the character plus showing where we added or changed a line of text. Okay, so now we're going to commit. I forgot there is at least one thing on Mars that's not right. That's the comment that was added into the file. Once we do a commit, git status on branch master, that change has been committed. The working directory is clean. So again, I'm talking about a local repository and the changes that I'm tracking, and this commit information is now in that log file. So you can move files around with Git and move files and directories. You can create directories. There's a lot you can do with Git that are Unixy-like. Not all Unix commands are defined in Git, but many of them are, and they do the same things. So you can move a file using git mv, the old path to the new path. And that's also what you would use to rename a file in Git. And it's the same as in Unix. If I want to rename a file, I use the mv command, because in Unix, everything is a file anyway. So Git will stage that change for you, just as though you'd edited the file and put new text in it. And then you have to call git commit afterwards to make the move permanent. And here's a screenshot of the changes. We've got 3 files. We're going to make a new directory, and we're going to move that directory. We're going to move Pluto into the minor planets directory. So we type the command git mv for move pluto.txt into minor planets / pluto.txt. Now it's Unix, so that we don't have to add the pluto.txt, but it's clearer for this example. And so now we see when we do a listing, we only have two files and a folder. And if we do get status, we're on the master branch. We will see we've renamed Pluto.txt to be in a minor planet / Pluto.txt. So that reflects the fact that we moved it down into that Unix folder. Then we're going to commit demoted Pluto to the minor planet subdirectory. We get back our state information. I type get status, everything is clean. So that means that move has been recorded. Removing files and directories with git remove rm. So sometimes you want to get rid of files or directories that are no longer needed. And so you want to tell Git to stop tracking changes to these files and also to remove them. You don't want to delete that folder, Minor Planets, on your own. That'll confuse the Git repository, and then you can fix it, but you have to go through a little bit of work. So let Git do the changes to the files. You can add new things and then tell Git to add them in, but once something is being tracked by Git, you want to use Git tools to make changes to the Git files. So you have Git remove the path to the file name. This does not remove the file from your repository's history, it only removes it from your working tree going forward. So you could still go back to a former version and get that. Let's say you remove it and commit it and you realize, I needed that folder. I removed the wrong one. You can pull it back out from a previous version. So then you have to run git commit after git remove to finalize the change. And here we remove the minor planets folder, and here it shows deleted. When you commit -m stop tracking the minor planets, that commits it. And then maybe we don't like that comment, so we amend that comment. And then do the commit again, and we do get status, everything is clean, and the minor planets folder is gone. So now we get into this concept called branching. Git branches, when you want to begin modifying the contents of your repository, but only want to do so without affecting the whole system. You branch out, you make a branch, and you work on that branch and then merge code back into the main repository. So we use branching and merging. To create a new branch in your repository, you use the command git branch, and then you make up a name for that branch. Excuse me, or it already exists. To then begin working on this new branch, you need to switch over to the branch of the project using the command. And with that, you would check out that branch. That's how you would switch into it logically. This is a virtual, so in your folder, you'll be in a branch and it might look the same, but you have to then start tracking which branch am I in. By default, branch in every Git repository is the default branch in every repository is the master branch. And now they call it the main branch. There are terminologies that are not encouraged to be used because they're hurtful, and master is one of them in the Git world, and the new repositories use the word main. So I'm going to change that. And that, if you look at the Exceed Code of Conduct, they have a web page that talks about terminology that we try to avoid using. So again, we're trying to always be aware of that. So I will fix that in this slide when I update the slide to reflect that. It's really going to be called the main, but in the older repositories, it's an issue of what these older repositories are called. And I think Git might be trying to update that naming. There's a whole area that we would probably need to go into at another time. Anyway, I will fix that when I'm done. All right, so here we're going to make a branch called Earth, and we're going to check out Earth And now we're in the branch earth, and we're going to make add a comment to the earth.txt file. And if you're new to Unix, the echo command will echo whatever you put after it. But in these two right arrows are the append command in Unix. So this echo, the it is not flat, will be appended to the earth.txt file. So if you were to look at the contents in the edit mode, you would see it now has that in there. So get status. Notice now we're on branch earth. In earlier, we were on branch master. All right, and so these are two different branches that will be tracked by Git. And Git will know if you change the file in the earth branch or in the master branch. It tracks that for you. And so this way you can have a copy of your project without having to duplicate that directory. It just is right there in the branch, tracked by the Git's software management system. Okay, so the changes aren't staged, but we do know that on the Earth branch, there's a file that's been modified. Now we want to commit that. So we're going to add that change to we're going to add the changes we made to earth.txt in the earth branch and commit that to create a new branch for earth.txt and added more Carl Sagan to the first line of my description. So we've created the new branch for earth.txt and added more Sagan. There's the comment that we just put in there because we did the commit. And now I'll do a git log and see that again there is a recording of that change. And so now if I type the command git branch, it will tell me how many branches I've got. And then if I do a git log, look at the last one, it will remind me that I created a branch and I changed one of the files. So then I want to get back into the master branch. And so it kind of doesn't make sense that you have to recheck out the master when just a couple changes ago you were in the master. And to me, why doesn't it say Git change to master? But it really, the way Git views it is all the software is in its repository database and all the changes are in the database. So if you want to work on one of these branches, you have to recheck it out. And you check out and check in and check out and check in all your changes all day long. And so if you want to move between branches, you use the checkout command. That's really what they mean by that. And now I'll be back in the master branch. Notice I haven't done a CD on my laptop to get into a different directory. And I look at the log there, and the last log tracked in the master branch was the one where we stopped tracking the minor planets and we had deleted that one directory. So the master has now different contents than the earth branch. And to work in the two, to switch between the two, you use git checkout master, git checkout earth. And Git will always tell you which one that you're in. And so if you're working with lots of branches, it can get confusing. So always double check. It's like being in, a hotel where there's 10 rooms, 5 rooms, and they all look the same. And you just have to, what room, you open the door and check what room number am I in because they all look the same. It's kind of that analogy, but make sure you know which one you're in. And again, if you get confused and you make a change in the wrong branch and you commit it, and all of a sudden you have too many things that go online, there's lots of explanations for how to backtrack and get back to where you need to be. You can reset things, you can stage changes, you can recover, and that's Marty's talking about that in the parallel session this morning in Advanced Git. But online, if you don't know about Stack Overflow, you want to join Stack Overflow. They have brilliant email message threads that almost anytime you Google questions in the coding world, eventually one of those links that come back will be Stack Overflow. And it's just a great place. It's a well-run site and very, very, very informative. And remind me to put that into the general messaging thread, Susan, so I don't forget, or Mahi. If Mahi could do that, that'd be great. Once you discover Stack Overflow, it's very, very helpful, even if you're not talking about Git and it's any other coding problem or any technical problem, and they cover everything from web page development to anything technical and scientific. Okay, so anyway, we now know that we've in the branch master, we've made a change here. We echoed a change into the earth.txt file. It's more like an oblate spheroid, and then we need to get that committed. So we add that new version of earth.txt. We commit the change with a description, and we're done. Okay, so once you've made these commitments, you want to you have two branches with two different pieces of information. We want to merge these and get back into one main branch. Usually the branches are made for a temporary purpose of modifying some code, especially if you're working on a team, but you want to be able to modify some code, do a little bit of testing, and then merge it back into your master branch. For example, if you're working on your own software project, like when I was doing my dissertation, it was a computational fluid dynamics application, and it probably had 15 or 20 modules in it, or subroutine files. It's Fortran, so it had different subroutines and different versions of these subroutines. And so it got pretty complicated. And so as I made changes, I was basically treating the Git repository as a project. And in fact, we did upload it to not GitHub, but another site. So my team members could track my changes and pull out software from my code that they wanted to use. So making these changes, being able to check out a branch and work independent and not worry about making a change that brings down everybody else's code with those side effects I talked about, it's really essential to learn this. So if you're just starting out in Git, take some time to learn how to work with the branches. And these examples today are standard from a standard example, but play around with your repository and get to know the branching and merging. Okay, so anyway, to merge changes from different branches, you first need to check out the branch you want changes to be merged into. So check out that branch, then select changes from another branch to be merged. Git merged. So I'm in the branch I want the changes to be brought into. And then I will say now merge changes that you find, and hey Git, merge the changes that you find in this other branch into this branch that I'm in right now. Now there's a conflict, so we have to resolve that conflict. All right, and what is that conflict? So Git branch master. So I was in Earth, we made some changes, and now I'm gone back into the master, and I'm telling Git to merge the Earth branch with the master. Auto merging Earth, conflict, merge conflict in earth.txt. Automatic merge failed, fix the conflicts and then commit the result. And if you look in earth.txt, Git's very nice. It puts the conflicts into the earth.txt file. It says head a pale blue dot. It's more like an oblate spheroid. A pale blue dot suspended on a sunbeam, but it's home. It's not flat. So you have these two versions, and we fix and keep the one that we want. You can keep one or the other, but what you have to do is edit the file and remove these lines. And then that will tell Git when you've physically gone in and edited the file and removed these lines that you've now merged it. You're the editor. You've made the decision, and now you'll do Git checkout Earth. Go back in there, and we try to do the merge, and we have to resolve the conflict again. We edit Earth and clean up and get rid of these conflicts. We have to go back into the Earth repository and look at a status. You're on branch master. You have unmerged paths, so we're not quite done yet. We add the modified changes and commit them. And now the conflicts are fixed, but you are still merging. Changes to be committed is earth.text. Make a comment. I'm merging earth.text from the earth branch into the master. And then everything is clean and tracked. And so the git commit merges the earth.text from the earth branch into the master branch. So when we do the exercises, this one you'll have to track. And if you do it yourself, then you'll find you understand what's going on. Okay, so we look at earth.text and it's got the correct changes. And now I'm going to go back into the earth branch and double check that, yes, I've got the new changes that I want. I'm going to go back into the master and I've satisfied myself that I no longer need that branch, so I'm going to delete it. And there is no more branch earth, and I'm done with that particular branch. Any questions? Okay, so time goes quickly. Then let's get back into the presentation and talk about GitHub. We don't have time to do any demos right now. All right, so GitHub is an online website basically that has the Git repository database behind it, and it's free, and you can make an account. And for example, here's Marty's GitHub repository with different repositories, the more popular ones, and I'm sure he's got a few more than when he took this picture, this slide. So you want to create a new repository. So here is a reproduction of what we did manually, that he's making something called planets and giving a description, making it public so that people can see it, and initialize the repository with a README file. Usually we use those, but he's not going to by default. And you can click on Create Repository. And the same thing will happen is this will be a repository, but this will be online at the moment. So it's the same cycle, but it's not on the laptop. It'll be on the GitHub server. And so when you do get that repository made and you go look in it, there's a message in its README file that if you're going to create, now you've created this repository, you want to populate it. So in this scenario, we're going to clone the repository and add to the repository information using the command line. You can create new material for that repository, or you can push an existing repository from the command line into this new repository. Or you can import code from another repository. I don't know if you can see this information marker, but I've got that in my way. All right, so in this case, we've made that repository online, and now what we're going to do is take this branch, from the local repository and push it up to the online repository. So git remote add origin to this repository that we just made on GitHub. And then once I've done that, I've told Git, okay, be ready, you're going to push everything up to that online repository. Git push -u origin from the origin to the origin, push the information, the code from the master. And you need a username and password. There's a caveat on that. They've now changed how GitHub works, so you have to use passwordless SSH or tokens instead of username and password. But for these examples, it worked a while ago. So once we get that, Git goes through all its messages associated with pushing information up to the repository. And so then I want to make sure that I go add that branch. and then tells me Git branch dash A tells me all my branches, and I've got the remote and the master locally. So what is happening is the planets locally are going to get pushed to the remote. So now the GitHub is called the origin, and then I have my local copy of that repository. So I've now converted my local GitHub repo um, into the being a repo hosted on the GitHub repository. And if I look online now, you'll see that my planet data files have been pushed up onto the remote repository, and you can see it on the website. Now I want to clone this repository. So I'm going to clone it. So what we're doing is starting over. So let's say we want to take the scenarios. Now we have to take that repository and get it onto Expanse or Comet. Comet is the system we had before Expanse. So what I'm going to do is clone that repository. And you can get the clone command from this cloner download command. And one thing that has changed is you want to make sure, if you want to be able to make changes because of the new identity credential system, you don't want to clone with HTTPS. You want to clone with SSH so that you have an authenticated, downloaded, cloned version. Okay, so we get the clone, and now cloning into planets, we get a copy of that repository on the Comet system, and we're going to add to the configuration information the name of I'm already added in some identity information because Git needs that identity information. Okay, and so now we have looking at the Git log, we now have this cloned repository on the Comet system. And we'll use Git clone all week. You'll be cloning from presentations and tutorials presented by everybody for the rest of the week. So try practicing Git clone if you haven't used it yet. And so we look your branches up to date with the origin master, and you get a response back. Looks like we're going to make a change to mars.txt, and we do a git diff, and we find that there is a change. So we pick the change we want to keep by editing, and now we're going to add that file, and then commit the change, push that change back up to the remote GitHub repository. And now we've edited the file locally and pushed the change to the remote server, and that's been recorded and stored on the remote server as well. And this is how you share code among teammates. And so now we have the change reflected. I know we're getting close on time, so I'm going to try and wrap this up. And then a caveat, like I said, there's a lot going on in the Git world. And you need to have some kind of token authentication or two-step authentication, which I haven't had to do because I already had the authentication and I've had a token for a year or more. So it's changed. I noticed that yesterday when I was trying to do some work. And so I'm not sure what will happen as you guys create new GitHub accounts and how they manage the token process. But we can help you through that. If you're having trouble and you have an issue, go to the help channel on Slack, and we're available, and there'll be somebody online to help you fix that problem. But in general, for the rest of the week, you're just going to download versions of our training repository, and you won't be allowed to upload or expected to upload any changes. So just using the HTTPS to download the training material is fine. Okay, so summary and conclusions. There's a lot of benefits to version control. You can archive, you support reproducibility, you support collaboration so that your changes don't hose everybody else's work, and everybody can help make sure your changes are good and vice versa. It's accountable and recoverability. If you do make a change and it's like, oh, I deleted my whole thing, my whole directory, you can recover pretty easily. So that's really great for software development. And with that, it's useful, but it's not essential unless you're a computer scientist. Thank you for your time. And with that, I'll end the show.